Hi, I'm Jim Wilson. I want to welcome to our class here on high voltage testing tools for Megohm and Milliohm meters. We're going to be using these tools to test the hybrid vehicles and the electrical vehicles that are coming to the market right now. So let's go ahead and get started on our class. I want to welcome you to the class. We're going to be covering the meters that you're going to be needing to purchase to do the testing on HV and electrical cars. We're also going to be showing you some information on how to do some hands-on testing. But let's look at the learning objectives that we have here. First thing we have introduction to high voltage and high current testing tools and processes. You have to think a little bit differently. You have to get your basic electrical in now, and this is the next level of testing that you're going to be doing when this goes across. The biggest thing about it is there are different testing tools than you had before. I can't use my Fluke 87 in testing these vehicles. It just doesn't do the job because we have higher voltages going on. And the big thing about it, I've got it in the black there, this is safety. You have to be able to protect yourself because you can have an issue where you're going to get, actually you can get killed in part of this if you do not do your testing properly. So they want to make sure the safety is there. We're going to start with a simple complex setup. We're going to go simple to complex again. We're going to make sure that you follow along and we do the procedure we look at. And there will be some hands-on learning we're going to show you go across. Now, the big thing about it is this is ancient. This is called a Megohm or a Megohm meter. If you look at it, it's in a wood box. This thing has been around for years. This is not new. So we want to look at what it is. So what it does is a meter designed to test high resistance values of insulation. So these high voltage lines, you have to check the insulation so that someone does not get hurt or something doesn't affect another circuit. So we surround the high voltage, high current capacity wiring such as on an EV or HV vehicle. The other thing, what does it do? If we're looking at it, I'm going to read down and look up there. What does it do? It puts a meter applies a high voltage DC output to the wiring on the HV or the hybrid vehicle. And if it's looking at it, that's what it does. And it uses Ohm's law to calculate insulation's resistance. I have to read that because there's a lot of text up in the process. It's based off of applied voltage and current off the meter. Now, the other thing, if we're looking at this process, if we come on down and look at some other information, how does it do this? It applies hundreds of values. So most of the time you're going to be testing about 500 volts. Well, keep this in mind. Your conventional meter, when we're checking resistance or we're checking something, it's probably going to be under 2.5 to 3 volts it's going to be applying, and some of them less than that. We're going to apply 500 volts across this circuit to check the resistance on it to make sure the insulation is good. So if you were looking at the process, why do we need to do this? I just told you, our conventional meters will not do this process. So what we need to look at is we need to step up to another meter level, the Megohm meter up here, and it's been around for years. We just haven't used it in the automotive field, and we're just moving into using it now on the current move to electrical vehicles. Okay, we have 2 meters up here. I actually got 3 meters up here. We got 2 conventional style automotive meters, and we have the 1507 that we're going to be using for testing electrical vehicles. Now, I put the meters, I jumper my leads together. You can do this in your classroom if you're teaching. It's a nice little deal. If I'm looking at this, I put this meter in ohms. I put this meter in voltage, if you see the voltage up here. When I'm in ohms, I'm going to read 11.09 up here because it's measuring the impedance on this meter. We have to be above 10. And right now we're at 11, so we're looking pretty good in a particular meter. And you always have to look at your nice little letter there in the process. So 10 megohms up here. Now, if I'm looking at this is all the voltage it's going to put out. Now, if I put this thing down in diode test, to trigger diode, you have to be a little higher voltage. You need to be at least a couple of volts up here. So I'm at 2.504 volts at this point. The big thing you have to understand is I have to have higher voltage to trigger it. Now, this still is not enough voltage to check the circuits on a high voltage system. So what we're going to do right now is I'm going to take my lead off here, take my black lead, move it over to the 1507, and take my red lead and do this. Now, there's a test button. Remember when I was talking about this, there's a test button here, there's a test button on your leads, either way you want to do it. So I'm just going to test the voltage output on this particular meter just by pushing this down. And when I push it down, you'll see we got 526.9 volts. 500 volts is coming out of this meter over to here. Again, all right, and when I let off there, you're still going to see the 10 megohms up here in the process. It's actually measuring it, telling you what we've got. Now, that's at 500 volts. Now watch what happens when I go over here and turn this meter up to 1,000 volts. And when I put 1,000 volts, because we will do some of the testing at that point, I put it there, it just goes overload, out of limits, out of luck, depending on how you look at it. Some meters will say, ouch. And if you look at this one, it's just telling me that I don't have the range in this particular meter to handle that kind of voltage. Again, at 500 volts, you'll see it, and it's going to measure back and forth. So in other words, we're testing the meter out to see if it's working properly. This is something you should do with your students, because sometimes they'll buy a meter and it's not got the megohms at 10 that we need. I've actually had this testing on sometimes like this, and they have less than 5, and that's going to affect the circuit you're testing. So this is a real quick review of what we look at. So we're looking at this meter is going to put almost 1,000 volts out when it's testing. Something you need to look at. That's why we have to move up to the more expensive meters and another level of testing. On safety considerations, when you're doing this, you want to read the tool's manual. You want to make sure you're using the tool appropriately. You're making sure that you're using the tool safely with the process. The next thing is you want to look at CAT ratings. Some of your voltmeters that you have, conventional voltmeters, will have a CAT rating of 1,000. But those leads are used with that meter. When you go up to a high voltage testing up there, you want to make sure the leads that you have stay with that meter and are assigned to that meter or that process. So a Megohm meter is going to have a different set of leads than your digital voltometer does. So you have to make sure you're looking at it. The other thing is you have to start off with personal protection equipment, PPE. You're going to hear that a lot if you're going through some of the tests, L3s and the other ones up there for hybrid. So when we're talking about personal protection, we're looking at some people are going to wear gloves, or going to wear cotton gloves, then they're going to have a rubber gloves and a leather glove on top of that for protection. You're testing this circuit, you want to have all the protection you can to make sure you're not going to get shocked, or you're not going to be, your heart might even stop if you hit it at the wrong point. The other thing is personal protection that most people don't think about is if you're working on this circuit, one other thing you should do is have some protection around you to make sure nobody just comes up to you while you're working on it. So there's sometimes you're going to put out the cones like you would do on the road. You see those orange cones? You might be putting a cone around, or you might be using tape around as you're doing it around the surface or around the area that you're working. One other thing you might want to do is just sign a particular bay to electrical testing on your process. That way people are not just going to walk in on you while you're there. Second thing you should always do is you never do testing totally alone. You always have a partner when you're doing this, because there are times that you might have a problem. If you go to Ford's setup, they will tell you they have what they call a shepherd's hook. Well, that shepherd hook is to pull you away from the electrical circuit if you actually did a high voltage circuit and it hits you and you want to be pulled away. Because the minute you hit that high voltage circuit, you will grip it harder. The last thing you need to do, as steps is read the repair manual, because the steps that you usually take for granted on a car aren't the same on a high voltage circuit. They are different. Electrical circuits are totally different on when the voltage starts going up. And you want to make sure you're doing it properly, get the right readings, because sometimes they're going to recommend you do a certain procedure, so follow the repair manual. Once you get the hang of it, you will not have to always look at it because you know the procedure. But when you start doing this, read the repair manual and follow the steps. That's what you need to stay safe. Let's go over to our next slide on some of the meters we're going to be looking at. All right, the Cadillac of all meters is probably going to be something from Fluke. So this is a Fluke model 1507. And you're going to have to look at the meter and the budget you have to buy. Somebody's going to have more money, some of you are going to have less money. And also if you're at a school, you have to wait sometimes to do your yearly purchase. So you're going to have to decide what you want to buy. So we're going to go look at some meters, and we're going to look at some process that you might want to think about when you're doing your search for the meters for the shop you're using. So the first one, we got a meter up here, test voltage of 50 volts, 100 volts, 200 volts, 500 volts, and 1,000 volts on this particular meter. The resistance range is 0.01 megohms to 10 gigaohms. Has a great big range when it's testing. The accuracy is plus or minus 1% plus 3, which is kind of interesting the way they do that. And the safety reading on this is Cat 4, which is 600 volts. Now, that meter's doing its job. If I go to my next meter up here, this is another option you might have if you're looking at it. And this is X-Tech. Now, if you look at X-Tech, it's going to do 250, 500, and 1,000 volts DC. The resistance value, if you look at it, it's 1,000 megohms, it's 200 megohms, and it's 2,000 megohms. Kind of interesting the way they do the things. Accuracy is plus or minus 3%. Now, this one is rated at what? 1,000 volts. There are times when you're going to want to look at 1,000 Cat 3 and times you'll look at a 600. But again, depending on the circuit you're working on, you're probably going to make sure you're twice as much as the voltage is what you're looking on your ratings on it. Now, the other thing is this is Klein Tools, all right? This is ET600. You look at the voltage readings up there, 125 to 1,000 volts. Resistance up to what? 4,000 megohms, all right? The accuracy, if you notice something interesting, is variable of the reading and the number of segment discs and digits. So if you're looking at that, you're going, okay, that's there. This one is safety reading at Cat 4, 600, and if you look at it, Cat 3, which is 1,000. And if you're looking at the information up here, again, you're going to have to decide what kind of meters you're going to buy. If you're teaching in a school, you might have to have one major good meter, and you might have to buy several smaller meters that are not as well constructed because your budget's stretched a lot of times when you're doing tools. I know that from teaching at a school. I know that sometimes you have so much money to spend and that's what you can do. Other times you have less money to spend and you have to prioritize what you're going to buy at that particular time. This is another option. This one has a test voltage of 500. If you look at it, it has 1,000, 2,500, and 5,000 volts. Resistance reading on this one, if you look at it, it's 1 megohm to what? 200 gigaohms. Accuracy, I hate it when they read this up here, but it's 2% of the reading plus 5 digits. So if you're looking at information, that's kind of interesting. I'd like a breakdown of how to do this. Safety reading is 600 to 1,000 volts, again, on Cat. Now, if I go to this meter, there's another option. This is kind of interesting. This is what a lineman might use when he's out in the field. He is going to go up there and test the voltage of 250 to 1,000. He has a resistance of 1, that looks like 1 ohm to 5,000 megohms. Accuracy on this one is 2.5. But notice something up there. It does Cat 3, it does Cat 2, and also notice there's a little crank there. So instead of having a battery to generate the voltage that it's going to put into the circuit to check stuff, you're going to crank it up and move it down to generate it. It also has an analog gauge. These things are still being sold. They're still used by a lot of people. Might be doing some repair lines on telephone or electrical lines, but this stuff is there also. For the most part, I wouldn't buy this meter for a shop because I wouldn't trust half my students there cranking things and seeing what's going on. So I would go a little bit different. And we're going to go over some measurement levels you need with the meters and going across. That would be the next thing we're going to talk about to remind you to do it correctly. Okay, we're going to look at the units of measurement and when we're going out and testing the vehicle. The big thing you have to teach yourself and your students to do is always make sure that you look at the letter designation when you're looking at ohms. So 1 megohms is equal to 1 million ohms. Mega is 1 million. Notice the M is large, all right? If we go to kiloohm, that's always 1,000, it's rated 1,000 ohms up there, it's always a K. And that's always going to have a large K and the ohm signal. If you look at 1 milliohms, which is different, you're going to have a small m that is going to be used to give you a reference. So 1 milliohm would be 0.001 ohm. So that's a little bit of a very small measurement. That's something you would not normally see under normal testing on a vehicle. So keep that in mind. Big M, megohms, little m, milliohms. The last one we've got, it's called a microohm. It's equivalent of 1/1,000,000th of an ohm. And a microohm always has this kind of like a U symbol before it. Sometimes when you're testing a car and you look at milliseconds, you would see a U before it. But the same thing, we're looking at a U on this one, that would be a microohm. These are something you're going to be looking at a little bit differently. And the big thing about it is you must teach your students, or you yourself must get in the habit of always looking at the letter. Do not assume, that what you're going to be looking at is what you thought you would be. You want to make sure you got the right reading, and the only way to do that is always look at the letter designation when you're testing. Now we're going to look at some things we do on a tool as procedures to get started doing some testing. Okay, the first thing you should always do is check the fuse. No matter what the meter is and how you're going to test it, you should always check the fuse to make sure it's working properly when you're doing testing. It's kind of unique about this one. You don't have to plug the leads into it. You can check it. They have a self-check in there for the fuse itself. So in other words, we can just push a button and do this. So what we want to do is check the fuse before you get started. The next thing is plug your leads in. Notice this is a little differently than you would do on a Fluke 87 or your own personal meter that you might have. So what we've got is we've got the black lead and we've wrapped it around. That's in your common, which is black. And then we're going to be looking at the red lead also in the process. So if you were looking at the meters, a little bit different how it hooks up the leads up here. The next thing we need to do is set your rotary switch at 500 volts. That's what we're going to use. None of this 2 volts or whatever we're looking at for a regular meter. We're going to use 500 volts to test it out. And the first thing we're going to do is test out the accuracy of the meter itself. So we're going to put 500 volts. Taking your first meter, we're showing here that we're going to go across with a test button, and the test button on the tool and the test button on the lead do the same function. So it allows you one-hand testing, which makes it a lot easier when you're doing it instead of having to reach back for the meter itself. Now, if I'm doing this, I'm probably going to hit the one on the lead, makes it a lot easy. So what we're testing out here is a 1 megohm, nice little fuse, sorry. We're going to look at a resistor. So we're testing the resistor. Basically, we're testing the calibration on the tool, whether it can read properly. The first thing we're going to do is do this. And what we're going to do is go out. Now this meter is a little different. It's going to be a little bit different to it live, which we're going to do just in a few minutes here. First thing we're going to do is measure the reading, and it says 1.02 megohms. That's a big M. It would also tell you how much voltage is being applied while you're testing the circuit. So we're looking for a 500 volts to go across this circuit when we're doing it. So we're going to look at the readings we've got here. Let's go out and do this live and see how it works. Okay, we've got a meter up here. First thing we had to do was make sure the gloves are right if you're testing it. We're going to be looking at 500 volts here and occasionally, so we want to make sure we at least have the electrical gloves on. You make sure that you blow these up, make sure they hold air. That's one of the first things you look at. Next thing we want to do is check the fuse in the system. And to check the fuse, we put in ohms. We put the fuse in ohms, and you just want to hit test. When you hit test, you're going to look at it. It says 22. As the slide says, if it doesn't see this, it's actually going to set up and say that the fuse is bad. It'll say bad fuse. So we've got everything looking good there. Now, the next thing we need to do is go over and check the 1 megohm fuse up here. We have to see if the system is working correctly. So what I want to do is move it over into, let's see, I'm going to put it over in this system right here. And I'm going to take my meter and I'm going to touch it up here, make sure my leads are up here. I want to check this. I'm going to put it in test mode and hold it down for a while. When you hold it down, you should have 1 megohm. So what we're looking is basically, in a sense, we're checking the calibration of the tool as it's working. So right now, we know we're set up. We can do readings. They will be accurate. So that's the first thing you want to do with your meter. And you need to do this every time to make sure everything's working properly. If you're testing the fuses bad, you're going to have a problem. So if I let up here, notice it will say some of the other readings that we have. All right, so that's what we're going to do to get started with testing with the meters. Okay, to perform an insulation test, you're going to be doing a procedure, but you always should do what we just did. You should test your meter and make sure it's properly set up. It can read the proper reading. So what we're going to do is, first thing you've got to do is de-energize the circuit. You never want to hook up to this circuit if it's live. You want to make sure it's de-energized, and the next one you want to select your proper voltage level. Most of the time you're going to be using 500 volts that I've seen on most of the circuits when we're looking at it. Your black lead is going to be hooked up into the meter and attach a probe to shielded ground on it, and you're going to be able to do it as specified by whatever manual, and that might be a better way of doing it. So we're going to use alligator clips on this to do some readings, and I'm going to scroll down here and make sure all my notes up there. But here's the deal. There's a test button on the tool itself, and the test button on the tool itself will be orange. The test button on your tool on the lead will be gray, and you're going to use it as a probe. So we would go across and test this one. We would test it to the, across each one. We would test it to the circuit bracket we've got up here on the screen, if you see at the back. First thing, what should your meter read? Your meter should read 550 megohms or higher. That indicates the resistance is beyond the range of the meter. And it knows they have a little bit of a, if you look on the left-hand side of there, it has a little squiggle is there. That means you're being tested right now. And the voltage that was outputted at this point was 527 volts. Now, you're not going to be wanting to do this without some protection, so keep that in mind when you're doing it. The thing will calculate everything, and if it goes above that, the insulation is good on this particular circuit. Now, also looking at some other information, if we go down and look at it, again, if circuit is over 50 volts, if you've got it in a live voltage, over 30. So there's some parameters you might be looking at on voltages you need to look at as a reference. Okay, so the next thing we're going to do is next up here, we're going to do what it's called practice makes perfect. Well, perfect practice makes perfect, or good practice makes perfect. So don't be sloppy when you're doing this. Test it correctly. So what we're right now is doing, we're testing the system to make sure there's no insulation problem between windings. And we want to make sure there's windings packed up there. We want to make sure. And we want to make sure that there's no interconnection or problems with this. So the other thing we need to do is identify a problem. So if we identify a problem, if we hook up here on this one, we got hands up, thumbs up, it means it's looking good. This is a good reading on this particular setup. So if I go to my next slide, you will notice that if it looks at it this one, it would tell you that we have a problem. I have to be over 550 megohms. If I'm not there, we have an issue. But the other thing down at the bottom, you look at it, has 1 volt. So immediately it knows we have a problem, and the circuit is telling you, hey, you got a problem, you need to fix this, and you need to be careful while you're doing your testing. Now we're going to go out and do this live so everybody can see how to do this and make it a little bit easier for you. Okay, we're going to look at the 3-phase inverter wiring up here. And we're talking about 3-phase. This is up here. The big thing about it is there are 3 different things you need to look at. The system can be shorted to the, if you look at the grid, we've got a nice little mesh up here. That's your shield we're looking at. It can be shorted to the shield, or it can be shorted internally to each one. So the first thing we want to do is go out and check. And I'm pushing to the shield up here where it's wired up here. So if I test the first one up here, it needs to read 550 megohms on the process. So we got it. And it's also putting out 527 volts up here. I want to do my next one. That's on my V. And I want to do my W. Now, before you were doing this testing, I'll make sure I remind you of this, the system must be shut down. It must have no voltage up there. Anytime you do an ohms testing on the system, the voltage should not be there. You're going to put voltage in it to test it. There should be no voltage there. So make sure that the system is there. Some guys call it a live dead test, where they're making sure that the system, they check the voltage and they make sure they check the voltage afterwards to make sure the system is powered down. So we were doing this one. we're just doing this on a board. I don't have to necessarily do that. Now I could actually check on the other end of the other connector here, check it again. Now the next thing I want to do is go between the U and the V. And notice again, got 550, so that means the system's good. That's what we would consider open. There's nothing there. There's no short to anything. Then I would take my lead and move it over, and I'm going to go from V to W. And you have to hear it beep. Once it beeps, it takes a reading. It stores it there. So we got 550. So far, all our system is working properly. Again, I want to make sure you understand, I can test it here, or I can test it here. Doesn't make a difference where you test it, just as long as you do test the system. Make sure all this wiring is good. Now, if there was a direct short here, the way this is inverted wire, there is a chance that you're going to short to the chassis on the vehicle or the body. So you don't want to have any of the stray voltage going around. You have to prevent it. So that's why we're doing this kind of testing. Notice my reading always stays there until I hit the button. Again, it always remembers until I hit the button, then it takes a reading. So that's what we use a meter. So that's what we're doing in this testing. You've got to do this to make sure everything's properly working. Okay, we're going to look at the Milliohm meter. Now this is a precision tool. A conventional DMM cannot measure small resistance in electrical cables or connections. So most of the time you're going to have to do that by doing a voltage drop, and that's not always as accurate as it could be. So a milliohm is precision. It's going to measure the interphase windings of the stator on the vehicle. We have 3 stator windings there. It's going to be U, V, and W. So what we might want to do is hook up and check our meter between U and V, V and W and U. That way we can check the resistance on the process. You also might want to check one of the windings to the core or the stator housing up there, the point that you can look at. The other thing is there's some Toyotas that are going to have a code that shows up with PA1B. And a PA1B, I'm going to make sure my notes is here, and it says it requires you to check the continuity and integrity of the wire. So basically what we're looking at when we're doing this test is the degrading of the wires in the stator itself. So if we have a high resistance, you want them all to be really close to resistance. If they're not, it's not going to be able to allow this thing to rotate properly because we're pulsing the windings on the system to make sure that we're going across in the motor. So we're making sure that we have an accurate milliohm meter. It has to measure 1 milliohm, which is 1/1000th of an ohm. So if you were looking at this, one other thing to keep in mind, these are temperature related. You're not going to test this immediately after that vehicle comes in. To get the proper readings on this vehicle, you probably want to let it sit for 8 hours. In other words, like we would do a cold start on a regular gasoline engine. We're going to let it sit for 8 hours. And the spec that a lot of time you're going to see is somewhere about 68 degrees Fahrenheit or 20 degrees centigrade. So when those tests are there, that's going to give you the resistance spec at those particular readings. So if you're not real close to that, you're going to have an issue. So some of these milliohm meters actually have a temperature correction that you can use. It will make it a little bit easier to use the particular meter and correct for that particular temperature. Again, if you're doing this, you're going to have the vehicle shut off for at least about 8 hours to let it cool down. That makes your readings within spec. If you're trying to do this real quickly, it's not going to work. You want to make sure you follow the specifications and test procedures correctly to do the thing. Now, there are some safety considerations on this one. First one, like I've said before, read the manual. Now you got 2 manuals to read, and they're pretty complicated sometimes. So now I have a milliohm meter that I need to look at, and I have the insulation meter I have to read the manual. So you need to read them. The other thing is there are always going to be some preliminary stuff that you need to do. The next one is you have to use the what? PPE. What was PPE? PPE was proper, it's protection properties. That you want to make sure you have the right goggles. You want to make sure you have the gloves on, and you want to make sure you surround yourself so that when you're testing it, nobody comes over and disturbs the car when you're doing it. What it is called PPE, again, it's personal protection equipment. Make sure you understand that. And if we're going through this, you want to make sure that we're looking at information. Again, there's a potential dangerous amount of current, very small going through this, so always follow the safety procedures. Now, if I go to my last one up, wait a minute, went up here. So if I do this one, follow repair manual, I've already said that. You want to make sure you're following the repair manual for the procedures. Not all electrical vehicles are going to be exactly the same. They follow very similar principles, but a lot of times there's little variations how they test, little variations of what they want to do. So you've got to follow the information to make sure it's correct. So the other thing is, if we go and look at this, they have 4 leads up here. So if you look into particular leads, there is a sensor, it'll say sensor. There is a sensor on one side, and there is on the other side, it's going to do another function on the particular setup. So these leads have 2 wires going to each one of them. So you want to make sure that you're looking at it, and there's very small ohm meter readings on it, and they have the sensor. So you have one that's going to be providing this, one's going to read it, one's going to load it down, one's going to be the sensor determining what's going on in the readings you'll look at it. So if I was looking at the alligator jaws, it would look at it, you would see a different reading on one side. One's going to be marked as it says SEN for sensor, or it might just be plain, and the other one's going to be the other side, and you want to make sure you make good contact with these on the circuit you're using. Now, if I was looking at this as my start, I would there. Then what we're going to do next is look at some options that you could for purchasing a Megohm meter, a Milliohm meter, excuse me. So let's go over and look at that next. Okay, we've got some options of purchasing that you can do at different price ranges. This is the GW Instec. It's a model GOM 804 is what we have on the bench here that we're going to be using. And we have the measure of value of current of 1 amp. Notice it has a resistance of 5 milliohms up to 5 megohms, and that's pretty good ranges on doing it. Accuracy is 0.05. Notice the accuracy is really good compared to some of the other meters we've been talking about. So it also has a thing called temperature compensation. Why would that be important? Well, that would be important because it makes sure that you correct for variation in temperature. Remember, it was like 68 degrees we were looking at, or 20 degrees, or whatever it was, 20 degrees Celsius. So if you're looking at the readings up there, this will allow you to add a temperature correction on it for very slight variations in the process. So this is one example. We're using that. The other thing, this was a nice screen for you to use. The bigger the screen, the better for some of us people, especially some of us that got some age on us. Are more experienced, that's a better statement. The other thing is you can actually check a switch or relay or other components or some of the tracks in a computer. So if you're building circuits, this might be something you would want to use as a diagnostic tool, something like this. But go to my next tool is Hioki. It's model RM3548, measurable value, again, for current's 1 amp. They're pretty much all going to be that. The resistance range on it is 1 micro ohm up to 3.5 megohms. This thing's got a pretty strong range on it and has an accuracy of plus or minus 0.02. That's pretty good. It does have temperature correction, so that makes it a little bit better on the meter. This is one that I think Toyota recommends for their procedures and testing. So this is, if you work on a lot of Toyotas, this might be a meter that you want to look at so it matches the factory. If I got an X-Tech up here, again, the amperage current is 1. Notice it says 200 milliohms to 2,000 ohms. So the accuracy range on this one is not as good, or the range is not as good. The accuracy is 0.02. That's really good. No temperature correction on it again. And I think temperature correction is something that you probably want to have in the meter as a suggestion. We go to our next one up here, and it's AidTech. And this one is a VC480C. There are other ones out there on the market. This one has, again, the current's 1 amp. That's pretty standard across. I have 0.01 milliohms up to 2K ohms, so its range is not as good. Accuracy is not there. It's at 0.5. Notice the other one's at 0.0 something. This one is at 0.5. It has no temperature correction and has no auto zero. The temperature correction is probably more important than the auto zero in the process on this, but these are some options you might have looking at some meters you might want to purchase. Again, buy something that meets all your requirements in the price range you have, and some of your schools might have to buy multiple meters, so you might want to see that you buy a really good meter that does one job and maybe buy some cheaper ones for some other testing. Now, what we're going to go over to next is setting up the meter to do some testing up there and go over procedures for that. Okay, when we're setting up our meter, you have to realize you're going to set it up based on the meter you have, and there's some things that you have to change in your procedure. So we're looking at this one. First of all, you have to put the meter in. They have two leads up there. Those two leads up there, one has to be in the sense and one has to be in the source, because remember, one is the sensor we're going to be using to compensate, and one's going to be putting out the current we need to do to check the circuit. Now, if I go to my next screen up here, we have automatic temperature via temperature, or via whatever you want to say, a temperature probe. In other words, if you have an automatic temperature probe, it's automatically going to read the ambient air around this tool. That's fine. That works really good. If you don't have that probe, the next thing you're going to have to do is manually input the temperature of the ambient air where you're at, or the room temperature if you're doing your testing, which works out also as well as you can. Some of the meters will not have a temperature compensation for it. You cannot put it in there, so you're at a loss of compensating for the temperature. There's one other factor you can do on some tools. They have a conversion factor. So if your settings you're at 72 or 74 degrees and it has a conversion factor up there, let's say that the manual said you should be at 68 degrees and you're supposed to have this reading of ohms in the system. What you would do is hit the conversion factor, and that would compensate for the slight changes in the temperature and give you a reading that would be at the temperature that you would be normally testing. That makes it a little bit easier. So it's making it sure it's doing a conversion factor to convert over a temperature correction factor for you automatically. Some of your meters will do that, others will not. So you have to make sure you understand. Again, read the manual and make sure you know how to set it up. Now, the next thing, if you're looking at it, once the ambient temperature is outside air around wherever you're doing your testing, or the probe is active, all right, make sure the probe is active or you're doing your temperature setting. Again, some of the tools you will not be able to do this. You select TC, temperature setting on it. You want to make sure you have one other setting you look at is called temperature coefficient. And the temperature coefficient usually be found in your manual, but here's the deal. If your windings on this thing are copper, they're starting to use aluminum for some of the windings in some of these. They have a different coefficient of thermal coefficient is different on those particular metals. So you have to compensate for that. And again, you're using your tool to do that. It makes your life a little bit easier because you've already got compensations for it that you don't have to add or subtract. The tool's doing it for you. The next thing you need to do is zero your leads. And you're going to push the REL button. Just like on an 87 or 88, you push REL, it takes the resistance out of the leads to make sure you get it testing. So if I do this, hit REL, it should automatically say that it is zero. You notice on this particular slide up there, it says in green, it tells you the changes that you had in the readings up there. So it makes it a little bit easier. So the next thing we're going to do, we're going to go out and take our first measurement using this tool. Okay, we're going to show you the DC high voltage floor wire up here and make sure we still have to check that as much as we have to check over here. The big thing is we want to show you what's a good test and a bad test. So the first thing I'm going to do, there's two of them up here, and I'm just going to back probe over here and put my meter on. And you see I got my 550, which means that is good. Now, we know that one is good. So I want to go over to my second wire. Notice we got two wires up here. I'm going to push over to that one, get a good connection if I can. Push a button on that one and it says 550. Let's go back again. And right now I'm going back to this other wire up here, and notice I have a reading up there and it's not my 550 that I'm looking for. So it goes to zero. Well, if I was on a regular meter, that would be continuity. But I'm putting voltage into the circuit. So I want to see which means is that circuit is shorting to ground. So what I want to do is make sure, if I'm doing this again, see if I get a good connection here, let's do it. And sometimes you have to worry about your connection. Notice that it says 550, but if I go over and look at it again, get a good connection, which I didn't, it says zero, which means is there is a problem with the wiring here, so we know that we have an issue. It's not continuity because I'm putting 527 volts onto the circuit, so it means I have it open. I want to see the resistance there. If there's no resistance, we have a problem. If it goes to zero, we have a problem. It's not like a conventional meter where that's continuity. The other thing to keep in mind, we got this cable that we're looking here is very similar to this. I want you guys to look at, I'm going to have to take these off to get what, I can do it. If you look at the wires up here, they are very fine little strands of wire. The higher the voltage, the wire doesn't have to be as big. So on a 12-volt system, we know we have fairly good sized wires up here. Notice the difference on this one. We got a lot of them, but they're really fine. They're really down in size. So you might want to look at it. And again, as the voltage goes up, the wires can be smaller. That's another reason why they're going to these type of systems. Now, we've got that. We've got a few more tests we need to do. All right, we're going to move over to the Milliohm meter, and we're going to be doing some more testing. And we're going to test directly to the three-phase stator here, and we want to have to do a couple of things before we do this. First of all, when you're looking at your meter, there's meter up here, and one side's going to say sensor, and the other side's going to say, nothing on it on this particular one. So you want to make sure you plug it in correctly. Now, the other thing about it is we're looking at our leads. Now, our lead's a little bit different. If you look at one side on the lead, you're going to see it's blank. That's the current side. The other side is going to be the sensor side, so you have to look at it. And notice we have 4 wires instead of the normal 2 that we would have with our leads. Now, one of the things we need to do is zero these. So I'm going to put these together and zero the process. Put them together, and it's automatic. I'm going to hit the 0 button. And we look at the 0 button is doing the leads. Now, we've got a little bit of resistance on here, but when we do that, there's actually a marker on here that tells how much voltage has been pulled out of the system if you're looking at the process. So first thing we need to do when we're doing it, I don't have to do this, I don't have to have gloves when doing this one. So first of all, you want to do the system. I'm going to go from V to U, and it's going to kick out and give me the milliohms up there. Notice it's 34.951 or 950. These things are really sensitive. So the next thing I might want to do is come up over here and do U to W. See if I got a good clip on there. And it takes a while for the reading to set. Notice again, we're really close to what we had before. You're looking for a very similar reading on each section. If you have a possibility that one's reading out, then you know you have a problem. Now the next thing I want to do is do to my V to W. And if you notice, we're real close. So in other words, this test is okay. Now this makes it work real good, but if you were coming out and doing the testing, these are very temperature sensitive, these meters, so you want to make sure you have the temperature correction. If we would change the temperature, it will cause the readings down here. So you want to make sure you do that. And there's a big thing you can do. You could actually, if you're testing with your guys, just show them how to do this and just take a canned air and spray on it, and you will see the readings change because of the temperature. So this is what you're going to use this meter. It's a real quick test to use. We're checking for the three-phase stator. We have to check each one of the wires on it. We have to make sure there's no shorting on the system. Everything's working properly. So we're done with this, and it's one of the things you're going to learn to test. I hope you got some information you're going to be using on your purchase of equipment for the school or you guys in the shop. I want to make sure that you understand. If you have any questions, we can answer those. Also, make sure you check us out on social media. Go to our YouTube channel and also look at us on Facebook. You get a lot of information there. Now I'm going to open up for some questions.